I wanted to run over some of the answers for 7.5 homework because the notes, you couldn't hear them. So I wanted to make sure that you were understanding and that you had everything that you needed. So I'm going to go over the odds. If you just need a few, then you can fast forward through the ones that you need. I'll also attach this to the homework page. So for number 1, it says a plus 1 divided by 5a minus 1 over a equals 1. I'm going to make it a fraction by placing it over 1. My common denominator here is 5a, so I'm going to multiply by what I need. I don't need anything here. It already has a 5a. I need a 5 here, and I need a 5a here. So I have a plus 1 minus 5 equals 5a. I'm going to combine my like terms and put my variables on the other side. So I have a negative 4 equals 4a. Divide by 4, and a equals negative 1. So on your worksheet, it says check on the right-hand side. So I can go ahead and plug this in to see if it works, or I can pull up my Desmos and just put in the intersection point. So if I pull up Desmos here, for the first couple of questions, it's the first side was the a plus 1, so I have to write it as x, and the second side, or the right side, is just 1. So I want to see if that intersection point is actually negative 1, and it is. So my check would be the intersection point, which is negative 1. Is that right? Negative 1, 1. Yeah. So that would be what would be here, intersection point. And you can write that for all of them if that works for you. That works for me. All right, so let's look at 3. I'm going to do odds. So 3 is 6. I'm going to write this as x, 6x minus 6. That way I don't get confused when I plug it in. Plus 2x squared equals 1 divided by x squared. Looks like I already have a common denominator here on all 3 of my fractions. So that's good because I can go ahead and cancel them out. So I can just write my numerators just as is and see what happens. So we have a negative 4 here, 6x minus 4 equals 1. Add the 4, we get a 5. And divide, and x equals 5/6. So I want to hop over to my Desmos and see what that looks like on my graph. So I'm going to not show these, show this one. And I want to see if 5/6 is actually the intersection point. If I plugged in 0.833, or if I plugged in 5 divided by 6, I would get 0.833. So that is my check, which is 0.833 and 1.44. So that is the intersection point there. This tells me, yes, you did check it, and you checked it in your graph, which is totally fine. All right, number 5 says 4 divided by x plus 1 divided by x squared equals 1 divided by 5x squared. So my common denominator here is going to be 5x squared. So my first one, I need a 5x. My second fraction, I need a 5. And my third fraction, I don't need anything. So I'm just going to leave it like that. So let's multiply it out and get rid of that denominator there. We have 20x plus 5 equals 1. Move the 5 to the other side, you get a negative 4 equals 20x. Divide by 20. We get negative 1/5. So let's see what this looks like when we plug it into our graph. Did I write that down right? Yes, I did. Okay, so I want this one and this one. So it looks like, even when I zoom out, do they intersect at any point? What did I say? Negative 1/5, right? I'm not. Yep, it's looking like an extraneous solution there. So what I can do too, because that's tedious, right? What I can do is I can plug these in as tables here and put in negative 1 divided by 5. Let's see what we get there. And it's 5. Negative 1 divided by 5, and it's 25. Yeah. See, those don't match. They would match if they intersected, right? They would have the same point, and they don't. So this, if we look at it, it's not an it's an extraneous solution. Extraneous solution. Yeah. Unfortunately. All right, let's move on to number 7. We just have a couple left. All right, so number 7 says 4 divided by n plus 1 plus 1 divided by n squared minus 5n minus 6 equals 1 divided by n minus 6. So just like when you're simplifying, you do want to factor and see what happens there. If we factored that, it would be n minus 6 and n plus 1. So lucky for us, those match. So our common denominator, if we wanted to stack them like we did in the notes, n plus 1 is the first one, n plus 1 and n minus 6 is the second fraction, and the last one is n minus 6. So in order to find my common denominator, I'm going to pull those down. Whatever matches, you pull down. Even if it doesn't match, you pull it down. N minus 6, but we only pull 1 if they match. All right, so this is my common denominator here. And I'm going to multiply by what I need. I need an n minus 6 here. I don't need anything here. It's already got everything. And I need an n plus 1 over here. All right, so FOIL that, or distribute that out. 4n minus 24 plus 1 equals n plus 1. We'll combine our like terms here and move our n to the other side. Minus 23 equals n plus 1. Let's see, that's 3n equals 24. That's nice. Gives us a nice whole number, an 8. So let's see what that looks like on our graph. Just going to exit out of those. Okay, what was it? This one and this one. So I'm going to see, do they intersect at 8? Let's see what, oh, look at that. That's pretty nice. It does have an intersection point. It's 8 and 0.5. So in my check, I'm going to put 8, 0.5 to let me know that I've checked it and it's good. All right, let's do our last one, number 9. Number 9 says x minus 3 divided by 2x plus 10 plus 2x minus 12 divided by 1, because it's a whole, kind of like a whole number, equals x squared plus 3x minus 18 divided by 2x plus 10. So even though it looks messy, it's kind of nice here because we could factor this out, but we don't really have to because they're already common denominators. And all I have is a 1 here, so I just need to put the common denominator multiplied by my second fraction here. This one doesn't need anything, so I'm going to go ahead and write it down, x minus 3. We got to FOIL these, so we get a 4x squared plus 20x minus 24x minus 120 equals x squared plus 3x minus 18. All right, there's a lot going on, but that's okay. We'll just go ahead and combine our like terms and see what we get. Anytime that you have something long like this, always write it with your largest exponent first, and that could help. So I have 4x squared. Let's put all of our x's together. We have x plus 20 is 21, minus 24 is what, negative 3x. Then on my numbers, -3 and -120 is -123 equals x squared plus 3x minus 18. Whenever you see an x squared and an x, that's my cue. That's my mental cue to think, okay, I got to get everything on one side and factor. That's what my next step is, right? So I'm going to subtract the x squared, subtract the 3x, add the 18 here. So we have 3x squared, -6x, and 120 and -18. 105. All right, that was better than I thought it was going to be. Equals 0. Okay, so let's see if I can factor here. I can pull out the 3. That's -2. I think this is 35. Equals 0. Okay, so what multiplies to get 35 and adds to get -2? It's going to be a -7 and a +5. So 0 product property says I can pull these apart, equal them to 0, and solve. So let's see, that doesn't make any sense. X equals 7 and x equals -5. So let's see what kind of solutions these are when we plug them into Desmos. So plugging into Desmos, let's see, I want to make sure that I get both of them correct. Okay. So I have, is that correct? 2x plus 10. Yeah. Yep. Okay, so I have two answers here. One is 7. So is 7 a correct? Yep, 7 and 2.167. That's a correct answer. That's my intersection point. 2.167. That's an intersection point. And then what about -5? So let's run over here. Oh, yeah, -5 is definitely an asymptote here. You can kind of see as we scroll out or zoom out. So that -5 is your extraneous solution. Just kind of think about this. It's not a no solution because you did get a solution. However, if you plug it back in, it is undefined. So we call it an extraneous solution, or like an asymptote, like we've learned about and we'll continue to learn about. So I hope that this helped you get through this 7.5. Sorry again about the notes. You know, that was a little bit crazy coming back to math and not having sound. So let me know if you still need help on any of these.